No. Okay, thanks a lot. Welcome also from my side. It's a bit a lengthy title. So what I'm going to talk today about is integration between an RDBMS and Apache Kafka. And the focus is mostly on Oracle. Some patterns I will show you also work with other RDBMSs, with other databases, but the focus, as I mentioned, is on Oracle. So maybe quickly a few words about myself. So I'm Guido. I work for Trivadis for quite a long time, 23 years. I've done a couple of things. I started working as a developer with PL SQL on the Oracle platform. Then I did some work with Java, with service-oriented architectures on the Oracle platform. And in the last couple of years, I started working with in the area of big data. So I came back to the data from like services in the SOA world, back to the data. So I'm mostly working with big data, data lake, fast data projects such as Kafka. And I'm also an Oracle Groundbreaker ambassador and Oracle ACE director. I have a blog where I post stuff regularly. It's you can see the link. What I'm doing mostly is I'm collecting news of the week around stream processing. So if you're interested in a topic I present today and you want to follow the news, then this is one source, probably not the only one, but one source. So it's not my own content. Usually it's other people's content, presentations, blog articles, and so on. And this presentation I present today, of course, will be covered in the next one. Just the slide, the link to the slide share. Good. About Trivadis, also very quickly, and then I dive into the topic itself. We're an IT services company. It's quite a good company. That's why I'm there for 23 years and I will stay longer for sure. We're operating in the German-speaking part of Europe. That's one big area. So Switzerland, Germany, and Austria. But we're also in Romania, and we also cover, of course, the French part in Switzerland. We're doing project business at customers. We're doing managed services. We have lots of SLAs we're doing for customers. We have lots of projects each year, from very small projects up to larger projects. We're doing training as well, and trainings also count as a project for us. So that's why we have these 1,900 projects a year. And we are 700 employees and growing. Good. What is the topic of today? I will talk first about the motivation and a bit of introduction into the product, so into tools I'm presenting. So the motivation, of course, is why do I care? Why do I need a bidirectional integration? You probably have heard about integration before, that you can do from Oracle easily with change data capture right to Kafka, or if you have been interested in that topic, that's probably what you have heard. But that's only half of the story, because it's only one way. And I will show you why it's important or interesting to cover both ways. And then I have two basic parts of my presentation. So I have blueprints, architectural blueprints for the one way, for Oracle to Kafka. And I have blueprints for the other way. I will cover, or I will spend more time in section 2, because section 3, the other way, is in some cases just the same products, but just using them differently. So I won't need as much time for 3 than I will using for 2. And then last but not least, the summary. As mentioned, please just note your questions in the Q&A, and I will answer or try to answer them at the end. So first, motivation, introduction. So why the whole story? If we talk about, let's say, modern application or the modern application development nowadays, then a lot of people talk about microservices. But my talk shouldn't be just about microservices. It should be more about maybe modern applications and how you build these modern applications. So what you try to avoid nowadays most of the time is building monoliths. You try to more decouple or highly decouple your parts, and you can call them microservices, but you can also call them mini services or decoupled applications. So what you end up at the end is with multiple blocks, M1, M2, and M3. And M is now here for microservices, but as I mentioned, it could be anything which is decoupled, which knows what it's doing. So you have concrete and strict responsibilities. This might be the customer, this might be the order service or applications, and they are very well decoupled. They have their boundaries. They usually end up having their own data, so they own their data. And if you really want to be decoupled, then you should try to avoid as much as possible synchronous communication between the two. What you should try to do is asynchronous. So you want to do asynchronous communication, and as an vendor neutral or as a vendor neutral term in an architecture, we use Event Hub for such a building block. You will see later this is going to be Kafka. Kafka is just one product, a very well-known product for implementing an Event Hub. On an architectural level, I talk about an Event Hub if I mean a product such as Kafka. But there are other products, especially on the cloud, which have similar properties. But in this talk, I will concentrate on Kafka as a product. So by that, we just pass messages to the Event Hub. Event Hub is publish, subscribe. We'll see that a bit later. So you publish a message and somebody else, M1 can, or no, M3 can subscribe for such a message and consume it. And M1 is only a producer of a message. If you do that in the microservice world, there's also the term of smart endpoints and dump pipe. What does that mean? Even if it looks like kind of more a traditional infrastructure where you had the middleware in the middle, this is still kind of a middleware, but this middleware is so-called dump. It doesn't do a lot. It only does publish, subscribe. If we talk about changing messages, if this message which M1 publishes doesn't really fit with what M2 wants in terms of maybe this is the order and he wants to consume the order, but he has an internal model which is different. In this world, you can no longer tell the middleware in the middle to transform. An Event Hub is not capable of doing any transformation. You have to do it in your own kind of environment, and probably you don't do it in the middle. You will do it at the interface, and this is called an anti-corruption layer. So you try, or you're responsible for changing the messages in a way or into a format so that you can understand it. And of course, you want to avoid that as much as possible. If you have, if they agree on a message format, because they all built a new system and they have all they have the flexibility, then of course you want to avoid anti-corruption layers as much as possible. You will see these terms a bit later again. And now the story where Oracle comes into the picture, or traditional applications built on Oracle comes into the picture. You see here databases. Each new service or microservice has its own database as well. And of course, this can also be an Oracle database, but I don't, my talk of today is not meant for these databases, because here you directly communicate with an Event Hub from the application. Here I mean more a traditional application built on top of Oracle, maybe with a lot of PL SQL in it, maybe with a quite thin UI, and I'm talking about these systems. So here we will definitely have a different format than probably what you want to talk here around. Not completely different, but probably a bit different. So here we will have an ACL as well. And now the question is, and I will answer that in my talk in the various blueprints, is the ACL near to the database or even in the database? So can you maybe do it inside the database using PL SQL and using the knowledge you already have in that yellow block? Or is the ACL, it can't be here because this here is the dump pipe, but you can do it on these arrows here as well, using tools on these arrows. Very important, it doesn't matter if it's here in the database or more on the arrows, it should be the responsibility of that application, just from a responsibility perspective. And then you're still doing kind of smart endpoint and dump pipes, even with traditional applications when you integrate them. A few words about Kafka. I hope most of you have heard about Kafka. I just want to highlight some terms I will use now later in the blueprints. So Kafka is just a publish subscribe system. If I say just, this is a bit, too simple. It's a very highly available and highly scalable publish subscribe system. There are people who are doing millions of events per second over a Kafka cluster, probably not over a cluster of just 3 brokers. You can just grow horizontally, scale out. So you add brokers, and by that you can scale. The absolute minimum for a production cluster, if you want to be available and highly available and a bit scalable, but especially highly available, you need 3 brokers. If you want the bare minimum, you could go to 2 as well, but 3 is better. And you also need a zookeeper with, again, 3 nodes. The zookeeper does some coordination work for the Kafka cluster. So this is needed in the middle. This is the event hub in the middle I showed in the previous picture. And then you can have producers and you can have consumers. Producer, they of course produce messages, or in the Kafka term, it's called a record, but it's a message or an event, depending on the semantics you use for your messages. You can also call it events. And here you can see a consumer can also wait for a certain time and then consume, and then wait again and consume again. And then he might get a batch of records which were queued or which were kept here in the Kafka cluster. Now you could say, yeah, this is nothing else than we had JMS in the past, so why do I need Kafka? It's a bit different than JMS in the past. It's much more scalable, as I meant, and the reason why it's much more scalable is that Kafka threw away a few concepts JMS is able to cover, starting from transactions, for example. You cannot consume and you cannot produce in a transaction, in a strict transaction, so you cannot do it in an XA transaction. And another important change is that the consumer has to know how far he has consumed. It's no longer the cluster or the Kafka cluster who is doing it. In JMS, you don't have to know as a consumer how far you are. You just consume, and the JMS broker has to know where you were, and especially when you're gone and you come back, the JMS cluster still has to know where you were, where you left off. Here, the Kafka cluster doesn't know about consumers. It's the consumer's responsibility to know that. And by that, Kafka has no state in the middle. And if you have no state, it's much more easy to do and scale out. So that's a few words about Kafka. And by that, because Kafka doesn't know about who are my consumers or who are the consumers of Kafka, Kafka also doesn't delete messages once they are consumed, because Kafka has no idea, are they already consumed? So the only way to remove messages is by specifying a data retention, which can either be a time to live, 30 days, for example, and then you keep all the messages for 30 days, and then they're deleted. Or you can also do never. So you can also use Kafka to provide a history of your messages. So if you do never, you can start at a certain point, and all your messages you add to Kafka will be kept forever as a history. And you can always, as a consumer, you have to know where you were, and you have to tell when you consume from where you want to consume. And assuming that you just read the new stuff, you were here, and now you read all these messages until here, and then you process them. And the next time you will start from here and process them. But you can you can also go back to the start. If you know why you're doing it, you can reconsume. Maybe you had a problem, maybe you want to test something, and if you have a history of all your messages, you can go back. And that's why an event hub is so important in nowadays architecture. That's why it's very important in a modern application setup that you have an event hub in the middle, and using this data retention brings you a lot of opportunity as an architect. So that's why Kafka is more or less set in modern architectures. And very important, a consumer is never pushed messages to the consumer. He is always pulling, and he's a polling consumer. By that, he can control how many messages he will get. Okay, so what will I talk about? I will talk about an artificial kind of setup with an event hub in the middle. Here is my traditional system, that would be the order processing system. Here I have some other apps. And in that case, if I have a new order, I would like to produce that from that system to Kafka, to this order topic, so that a notification microservice, which is completely new, could consume it and do something with it, notify the customer that the order is going to be shipped. And the other way around, I have customer here, but I also build a new customer system. So now I have customer information in both systems. And in that case, maybe the customer microservice will be the new leading service or leading system for customer information, but you will still have that table here. And now you want to sync everything which happens here. You want to sync with your table here. So this table gets more to a materialized view, but you have to keep that in sync. That's why you need the other direction as well. And by having both directions, not just one direction, you might even be able to have that system for longer. Because if you only know about one direction and you think that the legacy system will maybe the customer, that we will remove that. As soon as this here is ready, we will remove it. So we don't need the way back. We know I'm old enough in IT. I know that will never happen, or that will not happen as soon as we think at the beginning, because there are tons of reasons why we can't remove it. And we can keep it much longer, even with a good feeling, if we have a proper sync. And the proper sync means we need the other direction as well. And that's why we need bidirectional integration. In the blueprint, which I'll present now after the next few slides, is I always have this kind of, it's kind of green lights or kind of a categorization and classification of a blueprint. And I will have now a few slides about what does that mean, if it's flat or if it's aggregate. And then you hopefully, by that you can see what does a certain blueprint cover. Is it just flat, or is it aggregate? That will be either flat will be green or aggregate will be green, and the same thing with the others. So what does it mean, flat? Flat means if I have a database model, let's say the customer is not just one table, and that's of course usually the case, that you have multiple tables in your data model. Table A, foreign key to table B, or foreign key from B to A, to be correct. If it's flat, and flat means what do I have on Kafka? If it's a flat kind of integration, that would mean table A produces its own messages, table B produces its own messages. And if it's one-to-many, then we would have one message for table A if something changes, and we would have many messages, like many messages for table B. And of course, this is now very technical. Usually, if you want to do something, let's say this is a customer change, and a customer change is over 2 tables, you will get to a lot of different messages. But in fact, as a business event, you would like to have them together, which is really what aggregate message means. Aggregate message means it's not flat, it's hierarchical, like a JSON document, where you have your customer and maybe the addresses organized like that. So of course, aggregate would be much simpler if you can pass aggregates, but the question is, which blueprints can do that and which can't do that? Then we have the latency. Latency means how long does it take if I have a change in Oracle until it gets to the event hub, or how long does it take if I get a new event until it ends up in the RDBMS in the other direction. And I just have low and high, and I'm not classifying what does low means, but it's in the few seconds, whereas high latency is probably from a double digit of seconds to minutes. Then we have the ACL. I already covered ACL and already mentioned what I mean by ACL, where it can be. It can either be in the database or on the database using technologies that system already knows, or it can be in the data flow. So either DB or data flow. And then last but not least, license. Is it included in either the Oracle license, which you already have as a traditional system, in a Kafka open source or Confluent Enterprise platform, so the Kafka itself, but I have no features in my blueprints or no products in my blueprints which are only available in the enterprise platform. So it's everything is open source. or is it additional free software? So things which are not covered by this as additional free or open source software. And so then it's included. Additional means I have additional components I have to license in order to implement the blueprint. Okay, so now let's start with the blueprints from Oracle RDBMS to Apache Kafka. So all these slides or all the techniques I show you, I have implemented. In the previous slide, there was a link to my GitHub where you see the code. I've implemented most of it, not everything, but I would say 80% of it. So you can see the code there. I have some code slides as well, but I will only cover them briefly. Maybe if you have questions at the end, I can come back, but I will mostly talk or I will only talk about architecture here and about the blueprints. I have plenty enough, so I need the time, yeah, just to cover them. So for the green arrow, so from Oracle to Kafka in that case, so I'm a producer logically as an Oracle database, a producer of messages. I have 5 different blueprints. Here you see the link to my GitHub. 5 different blueprints, which I now present in a generic way first without products. And then I always have an overlay where I show you the products. And with the products, I'm then able to classify them according to the 4 different sections I've showed you before. So the first one, DB to Kafka 1, that's the notion here, is polling an RDBMS table or view. So in that case, you would have a data flow component. This is my event hub. This here is just consumers of it, could be a microservice, could be stream processing, but I'm not covering that in my slides here. But of course, you need somebody who is doing something with the message I produce here. So here, the idea is that I have a data flow component outside the traditional system, but still it would be in the responsibility of that system if you go this route. And this data flow component is just polling the RDBMS table over a certain strategy to see what is new in per table, of course, or per view. You can do it over a view, and you would just get the new message or the new data or the changed data. How can you do that? I mean, there are a couple of ways to do it. Here I have Kafka Connect. So Kafka is not just the broker part. It's not just publish, subscribe. Kafka also have a connector framework where you can run a Kafka Connect cluster and you can publish, you can deploy different connectors. So it's a connect framework and you have connectors. And one connector is the JDBC connector. And that JDBC connector can be used as a source connector. So by that, you can easily, just by a few configuration, you can do a polling loop over a database table and just using a strategy, for example, timestamp, to find out what is new. Of course, you can also do a full extract all the time, but you can also do delta. Because you sit on a table, the messages you get are flat because you have to do it by table. It's rather on the high latency because you don't want to poll your database every, I don't know, 1 second. You probably want to do it from, I don't know, 15 seconds and upwards, just in order to not overload your database. And of course, you also have to think about how often do I really have a change in the database? And that also, of course, steers the polling interval. You need a data flow, the ACL has to be done on the data flow. So if you want to change from what you get to what you have in the table, you have to do it here, because here you go directly on tables. Of course, if we would do it over views, then you have some flexibilities to do some stuff in views as well. And everything is included because Kafka Connect is open source, the JDBC connector is open source, and you already have the database. Of course, everything, or all the blueprints I show you today is either on-prem or could be in the Oracle Autonomous Database as well in the cloud. So Kafka Connect, that's it. That's how it looks like. You just have a connector or a source connector. It also exists on the sink. We'll see that later on the way back. We have the same pattern, just in the opposite way. And here you have the different connectors which are available. And I would just use the JDBC for Oracle here. Oracle database. And this is what you would have to do. It's very simple. You deploy the connector. Of course, you need the Kafka Connect framework running as a cluster, as a separate cluster to Kafka. And then you just basically have to provide which connector. So it's the JDBC source connector to which database. That should be familiar to you. And you can tell with the topic prefix and here the table whitelist. So by that, I tell I only want to get the order. And here you have the timestamp column, which is the strategy timestamp. So I'm doing it by timestamp. And here I have some transformations. That's how you can do limited set of transformation. That's where your ACL would be. There's some alternative products such as StreamSets, NiFi. There are quite a lot of data flow products nowadays. Kafka Connect is very simple. It's not very powerful in terms of if you have to do, if your ACL is more complex than what you see here, then maybe Kafka Connect is not the right one, but then you could do the same with StreamSets. It just comes back to the choosing the right product for the data flow tool or data flow building block, but it's still the same. It would still be a polling loop. The next one you probably have heard of is a lot of people, if they talk about integration between Oracle and Kafka, they mention change data capture. And change data capture, for those of you who are long enough or have a long time in history with Oracle, it's at the end Golden Gate. So with Golden Gate was used to just replicate data from one database to the other. But Golden Gate has changed and has also added an Oracle Golden Gate Big Data connector, as far as I remember. That's the name. And by that, you can directly write to Kafka. So all the changes you get via change data capture, insert, update, deletes from the redo log, you can now get as messages. And because the redo log is also by table, it's still a flat approach because you get one change per table. It's very low latency because as soon as something is written, a transaction is committed, you get that change immediately. ACL has, again, to be done here because the database just passes you how the database looks like, how the data model looks like. If you don't want that in Kafka, you have to do it here on the data flow. And it's additional licenses because you need Golden Gate, and Golden Gate is not free. Here you see alternatives. They also alternatives for change data capture. So there are some alternatives to Golden Gate, like Click Replicate, like Debezium, StreamSets Data Collector, but they're also not free. So that here additional is also correct over here. StreamSets Data Collector itself is an open source tool, but you have to be careful when you start doing change data capture with Oracle, with StreamSets Data Collector over Oracle. You have to read the licensing terms, and it might be free at the moment, but the chances that this will change in the future are quite high. The next one I cover is polling an RDBMS API. So what do I mean by that? I mean by that I have an API in the database. So let's say you already have PL SQL code, and the question is, can I invoke that PL SQL code? Can I use that? So I have a data flow component. I would kind of call that API. That API will deliver me all the changes or all the data I have to pass in here. How can we do that? We can do that by using Oracle REST Data Service. That's probably the most straightforward way. Of course, you can also implement your own Java application over here, but if you want to do it in a database or near, it's not in the database, but near the database, and by using PL SQL and that Oracle REST Data Service, that's quite a neat way to provide REST services on top of Oracle. And in that case, I would just do a read, a select, and I would pass the data. And I would need something like StreamSets here now, because as the data flow tool, which does nothing else than a REST call to that REST API, gets the information and stores it in Kafka. So StreamSets can easily work with Kafka. It can easily work with HTTP services. These are all components which are built into the StreamSets data collector. And of course, there are other products, again, Kafka Connect, NiFi, Spring, Camel. For those of you who know these tools, they could act as a replacement for stream sets. And they all have the same kind of category or levels here. It's now aggregate, because with Oracle REST API service or REST data service, you can also do queries over joins and then have aggregation. It's high latency because you still do a polling loop. It's the ACL is in the DB because I can show you a screenshot of a code sample where you can see how I can change from DB to an aggregate, and by that I can also change names. I could change data types, so I can do a lot about the ACL already in the database. So what I get here is already a proper message I would like to have here in Kafka, and it's included because Oracle REST Data Service has no price, no licensing. And there will be another talk, I think, just after the lunchtime, just about Oracle REST Data Service. So if you don't know about it, that's probably, and you want to learn about it, that would be a good continuation of today's conference. So just quickly, Oracle REST Data Service, it can be deployed on different parts: WebLogic, Tomcat, Docker, standalone. And what it does is just basically it checks the verbs, the HTTP verbs you send. So from outside, I just say a get, and then you can map a get to a SQL statement, a select statement, and you will get a return set. If you use post, then with post, you would also pass a message, and then you can do a conversion to probably an insert or to an update. And you do that in PL SQL. So you have an additional package where you can do an enable schema. So the schema is valid or is enabled for ORDS. Then you do a define module, define template, where you map an URL to basically a module or a package. And then you have a handler. And the handler is basically the important part, because now in the handler, I don't cover it in deep, but you can see I'm doing a select. I'm doing something with application JSON to tell that it's JSON, and then I have order date, and that this is the new field name on the JSON document I return, and this is the name on the table, and this is the table or the alias for the table, and this is my the PO is, where is it? I have order items, I have customer data, and somewhere is the order, which I use as well, which I can't find now here. No, I probably only do an order item, but you can see I do a left join to customer. So you can do, here is the order. So it's order, left join to customer, and also order item is used as a subselect. So you can do very complex stuff in order to get the JSON back. It's nothing else than getting JSON out of a relational data model. And that JSON is then what you send to your Kafka topic. That's how it would look like in stream sets. I have to speed up a bit. The next one is produced to the event hub from Kafka. So instead of using a lot of stuff in here, telling the database why not communicating directly to Kafka, or using a REST service, which we can have here kind of as an abstraction over my event hub. We're not doing that. This is not, I just mentioned it. I mean, it's technically possible, but I don't like it. For me, it doesn't feel right. You could do it with Java in the database, and you can try to write with Java in the database directly to Kafka. I have not even tried it because I think as an architect, it's just not good. That's why I didn't want to bother. And I can just imagine a lot of problems doing that, starting from producing the right format I want to have here. But even more problematic is the dual write problem. In that case, you would first write in a transaction to the Oracle database, and then the write to Kafka, you can't do that in a transaction. So you will never be sure if I commit the database transaction, has the write to Kafka happened as well? Or opposite, if I wait with the commit and I'm doing the write to Java, to Kafka first, I'm still not sure that it's really covered in one transaction. That's why I would not do that. The same with the REST proxy, we would still have the dual write problem. And I also couldn't figure out a really good way, similar to the Oracle REST data service, to do the opposite, to call out from the database to a REST service. I couldn't find a nice solution. Of course, it's technically possible. You have an HTTP package in PL SQL, but you have to do a lot of manual work, and I think it's just overkill. So I would not suggest that DBK4, there's no proper solution for that. And the last one, that's a nice one I really like. It's using queuing in the database and bridging it to the event hub. And what is queuing in the database? It's advanced queuing. Not all of you might know about advanced queuing or have used it, but it's there for a long time. There's topics, there are queues in the database. And by that, you can tell your traditional system just to use a queue. Maybe they have used it already, or tell them, let's use it, let's start using it. And now from PL SQL, or of course also from some other application logic, you can do in the same transaction a write to database, a write to queue. And then all you need is a bridge between a queue and Kafka. This is again a data flow, but that data flow would just consume from a queue and write to Kafka. And you can do that with Kafka Connect. And I've not shown that, and using the JMS connector. That's the missing piece here. There's a JMS connector which you can use to actually treat AQ, advanced queuing, just as a JMS broker. And that works. I've implemented, works perfectly. And then in that case, the ACL is on the database, because before you write your message, you can do all the changes. You can aggregate, you can put aggregates in here, and all you do in the bridge is just passing it onwards. And of course, low latency, because as soon as you write to the queue, the bridge can consume it and write to Kafka. That I will not cover the examples. And last but not least, for this one direction is AQ with a Kafka API. This is not a wish, but it's also not there yet. Oracle is talking about it or mentioned it a year ago. And they're working on it. I've just talked with somebody from the Oracle product management in February, and they're definitely working on it. So in the future, AQ will have another API, not just JMS. It will also speak Kafka. So you can use just your normal Kafka consumer to get messages from AQ. And maybe even longer term, if you, depending on the complexity of your system, you could even think of AQ as playing a part of this event hub, of the more central event hub, because it's now Kafka, and everybody who is talking Kafka could now use AQ instead of a real Kafka. But of course, we will have to see how good it works, how compatible it is. But that's an interesting part. And in that case here, this is just a mirror maker. There's a mirror maker in Kafka just for mirroring Kafka clusters. And at least theoretically, I cannot prove it because it's not there yet, that part. The mirror maker is there. But theoretically, you should be able to use the mirror maker to just move data from here to here. Okay, so that was one way. And I already said I don't need as much time for the way back, although the way back is very important as well. It doesn't mean it's less important, but some of the blueprints is just turning them around and using the same product. So here I will go over quite quickly, and I have one which is new, which is not there in the other way. And of course, there's also one which is not there, which is not available here. If you see, there are only 4. Before we had 5, because the change data capture is really just for one way. There's no change data capture over here because Kafka is basically publish subscribe. So as soon as something changes on a topic, you as a subscriber are informed immediately. So change data capture is basically baked into here. So if we just look at them, write to RDBMS table, sounds familiar to the select from RDBMS tables. Write to RDBMS API also sounds familiar. That's again Oracle REST. Consume from event hub, that will be special, something new, and event hub with bridge to RDBMS Queue is again advanced queuing, but just in the other way. So write to RDBMS tables is again Kafka Connect, for example, but also stream sets or any others. Then a JDBC connector here, the same one as before, but now as a sink. And by using it as a sink, the connector will consume from a topic, and whatever he gets as messages, he will try to write to the database. And you can either do it as an insert or update or merge. And of course, it has to be flat over here because you write to a table. It's low latency now in that case because there's no polling, because you immediately, as soon as you have a message here, the connector will work and you will do an insert. ACL, again, on the data flow, because here you have tables, you have to match the table. If it doesn't match, you have to do something here. And last but not least, the license is included. Maybe another word about you have to do it here. Of course, you can also look at this topic here and specify that topic as directly matching what you have here. And then maybe that topic is a topic which belongs to your solution. And the change from your kind of canonical topic or normalized topic to your topic could be done over such a building block here as well, over stream analytics, where you also just consume and produce. And here you can definitely do more complex things and over here. So that's just an option you have, which I forgot to mention before. Then the write over RDBMS API, again, is Kafka Connect, REST API plus Oracle REST Data Service, but now as an accepting post or put messages or delete methods and mapping them to the proper statement, insert, update, or delete on the database. Can be aggregate, as I can do selects over aggregate, you can also do aggregates. You can pass an aggregate like a hierarchical document and then do multiple inserts or updates. Low latency, of course, in the DB now, the ACL and license included because Oracle REST Data Service has no price tag. And here you can briefly see that this is customer and address. So it would be customer and, yeah, in that case, one address. But you can see there can be two inserts being done based on the data I get. And here I'm getting the data out of the structure needing for the insert. Okay, so now 2 minutes left. So that should be just enough to cover that. So now this is the consume from Event Hub. And here what we get, SQL access to Kafka. I had not yet time to try it out. If you're interested in it, here's a blog article from Oracle, from an Oracle guy from I think, product management, who explains it very well. The idea here is that you get a view on the database, and that view is kind of an external table, but it's a view, and that view sits on top of topics. On one topic, you can even separate it one view per partition because a Kafka topic has multiple partitions usually. So you can have one view per partition in order to be scalable. But from a logical perspective, it's a view. And now a view is like a view. You can just select from the view in order to consume. I'm not sure if it's, from what I've seen, it looks like it's only flat. There's no aggregate. It can only do JSON and delimited. But because I have not tried it out, I'm not sure if I can do aggregate JSON and it will accept it. Probably not, as far as I understand. I think it's high latency because there's even a functionality that you can say, this view should be automatically synced with a table. And then whenever you get something here, the view will sync it with a table and you have the results in a table. So it's kind of change data capture in the opposite way. You just have a table and the table is kind of magically updated by this view feature. ACL in the database, that's probably wrong. That should be data flow because I have to accept what I get. So I have to change that, sorry for that. It's still quite new. And additional license, as far as I understand, I'm also not sure, it's not so clear how the licensing will look like for this piece. You can get it with SQL Developer at the moment, but I'm not sure if that will change, if that will stay like that. So I'm over the time, so just that to cover it, Event Hub, bridge to RDBMS Queue, as I mentioned, just the other way around. Kafka Connect JMS connector to AQ. But now I'm reading data from here and I'm sending stuff to AQ, and then I would have a listener over here in PL SQL accepting the message and do whatever is needed on the Oracle database. As I mentioned, I quite like that approach. And if you think that Golden Gate is too expensive for you, maybe you want to think about AQ. And even if you haven't used AQ in the past, think about using it now. Because it's in my point of view, it's almost the cleanest way, except of change data capture, to do the whole thing. Because on that, over here, you should think about messages, and over here, you think about messages. And you only have a bridge in between the two. And over here, you don't have to tell them that they have to do anything with Kafka at all or anything new. It's just basically sending a message or retrieving a message, as shown here. Okay, so that brings me to the end. The Kafka API for advanced queuing, of course, will be similar. Then you can produce from here. Before we were able to consume, now we could produce, and it would end up in AQ, but the idea of using AQ is exactly the same. And yeah, that brings me to the summary, my last slide. That's what we have covered. In one way, the green, in the other way, the red. I told you why I think it's important. It lets you probably live with your traditional system much longer, which is not a bad thing in my point of view, because it might be still a very important system. But that very important system can participate in other developments. You can call it modern developments, split developments, but you can also call it other developments. Yeah, over time we had changed, but of course here we can have an Oracle database as well, but maybe the system is just structured a little bit different, and the system is structured in a way or built in a way that it communicates over Event Hub just from the beginning. It's kind of a first-class citizen in terms of an Event Hub setup. Okay, so that's all I wanted to cover, and now the questions. Are there any questions I can try to answer?
Right now there is no question, but I have one question.
Sure.
Configuring the AQ, how long does it take for one who has no experience using Kafka and Oracle AQ?
To learn how to implement it?
Yeah.
Mm-hmm. All the way to Kafka or just the AQ itself?
The AQ including the Kafka.
Okay.
So the complete screen you showed in the presentation.
Yeah. So if let's assume the Kafka cluster is already set up. So the infrastructure, let's leave that out of the picture. How to set up a perfectly running Kafka cluster. It's not very complex, but of course you have to know some things. But if you're only an user of Kafka, and let's say Kafka Connect, I go back to the one which is at the moment possible. Kafka Connect cluster is also there. Then all you have to do is this kind of property, similar to the one I showed you for the polling, would be a similar property file for the read in that case. With JMS, because it doesn't matter what connector you use. So that of course you have to understand, but it's not that hard, because you basically have to mention the queue in AQ. You have to mention the connection over JMS, and if somebody has already done it, you can basically copy paste these settings. On the AQ side, it's a few PL SQL packages. I skipped them on the slides, but you can create queues over packages. So there's a package create queue command and create queue tables. These are the two objects you need. And then there is a package for writing to the queue or consuming from the queue. It's a PL SQL package with a method called probably send. I don't remember it anymore. And that's also, if you're a PL SQL developer, it's very normal to use it. It feels normal. Okay. And I haven't touched it for quite a while, to be honest, because I haven't touched PL SQL for quite a while. And when I did the whole implementation, I immediately felt back at home, because I've done so much PL SQL work. It was so natural. And I think that's the advantage of the whole solution or of that blueprint.
Okay, perfect. Thank you. We have two questions from Thomas. One is from Thomas Pletter. He asked, are there experiences with some configuration which you showed us?
In real life,
I think so,
definitely.
yeah.
Change data capture we have in real life. Advanced queuing, to be honest, I haven't, together with Kafka, I haven't used. We as Trivadis, we have done projects where we have used AQ quite a lot. JDBC polling, definitely a yes as well, because if you don't have, I mean, if you don't have an Oracle database with AQ, then JMS polling or JMS write, so the first one, that one here, that also works for other databases, Postgres or whatever. Or let's say we have Oracle, but you don't have the money for an Oracle Golden Gate license, then JDBC polling, this polling loop and just trying to find out what is new, is just kind of a poor man approach for if not having the ZDC. And that's definitely in POCs is often a valid approach, but the downside is really that it's just higher latency in the polling, not here, but in the first one. That's the downside, but it's it's a valid approach, and it's a good approach as well. And the other downside, of course, is that you can't do anything in the database in terms of ACL, that everything has to be outside. And then it's, if I go really back, then it's, I just want to just cover that again or stress that again, because I think that's really important. If you heard in the past that the whole idea of enterprise service bus was a bad thing, it's not really because the products were bad. It was because we used it in the wrong way. And I've done it in the past also in the wrong way. We said you need an integration team. The integration team is responsible for the ESB. So if you have that situation and you use polling JDBC, then the ACL cannot be done on the database because you poll a table. So you have to accept what you get as a table. And you have to do it somewhere before you pass it on to microservices, because you don't want to pass your data model to all the new service, or the new services say, this is my data model, we already accepted it here. You have to present us the message according to our needs. So you have to do it either here or here by saying this topic is not directly read from here. So we write it first here and then transform it like that. And what I think is very important is that this has to be in the responsibility of this existing application. Mm-hmm. Otherwise, you end up in a similar situation as with ESB. You delegate it to somebody, they have never time to change what you need, the changes you need, and then you're always dependent. And I think that's not going to work, or it's going to work in a similar way as with ESBs.
Okay, thank you. Another question is from Christian Wimmer. He asked, would Kafka also make sense for messaging between traditional apps or Oracle databases as a replacement for database links to decouple the systems?
Database links, meaning that at the moment you would do, I have to think about what the database link is because I haven't used it for quite a while, but you would do selects over it. I mean, from a far away perspective, definitely a yes. Of course, you would have to change probably your application, because if you now use the database link and you just do a select over it, and you kind of assume that the table you're selecting is kind of a virtual table on your side, then that you would have to change. But I would say by you doing Kafka in the middle, I mean, you always have to think about what is the benefit and why are you doing it. If it's just if you only have these two systems and you only do it for these two systems, then maybe it's technically better. I would say it's more modern. It's more decoupled, definitely. You would have a buffer in between. It would also work if one system is not there, but maybe at the moment you're synchronous calls, so you assume that other system is there. Where you would gain definitely is that you have the event hub is publish subscribe. So whatever you publish to it, instead of doing over a database link, would be accessible for other consumers as well, because it's publish subscribe. It's never I publish a message and only one can consume it. It's always I publish a message and multiple ones can consume it, exactly the same message. And I think that's the benefit you would get. I hope I answered that in.
I think so. There's no more question. One is from Aidan McCarthy. Are these slides available online? I think we will publish them
Definitely.
Online so that everyone can see your slides, and also this record from this presentation, so everyone can benefit from it.
You can also find it on my slide share, just as if you just on slide share G Schmutz. I will just upload it after the talk.
Okay, perfect. Thank you. Thank you for your presentation and your time. One last thing. At 5:30, we have our keynote with Gerhard Wenzel. So please join us. It will be very interesting, and I hope to see you there. I know you're hungry, and so it's time for lunch.
Enjoy lunch. Bye-bye.
Thank you.
Thank you.